Hello friends, today I am extremely excited to start a new series on Docker. In this course you will know everything about getting started with Docker. We will begin with detailed discussion on primary component of Docker, the container, and why it is so important for us to understand this. We will learn this by extensively comparing the world before and after container. After this we will quickly see how you can install Docker. Then we will do quite a lot of practicals where you will learn how to create Docker file, build images from it. Then we will invest some good amount of time in learning primary Docker commands, which will definitely help you to get started with Docker. Then we will see how to create a container and run an application from it, and many more to come. This course is not only for the ones who wants to learn Docker from scratch, but also who wants to refresh the Docker knowledge. So let's get started. Let's start the course with what is container. You know what? Before that, do you know the primary component of software development? That's the scope, cost, time, and quality. The software development companies always tries to save money in all of them. Does Docker helps in saving companies money? Yes, immensely. It reduces drastically deployment time, enhances quality by helping in automating deployment processes, and ultimately saves huge cost. Let's see how does container help saving cost. For that to understand, we have to go back to the world before container. As you know, world is full of applications. Almost for everything we have applications, right? Now, let's say you have a company and you have an application to deploy to the server. Let's go back to the year before around 2000 and see how we used to deploy these applications. So back in those days, we used to have servers per application. And by server, I mean a big individual physical server for every application. It means for every new application, business needs to procure these servers, which definitely does not come for free, right? Instead, it comes with lots of cost and maintenance, like machine cost, license cost for all the softwares like operating system and all, power cost, cooling cost for individual systems, and lot many. And on top of that, any changes to these servers are not so easy. Say the initial system configuration does not support the current load of your application, or say for improving performance you have to enhance the server configuration. Ah, additional cost, right? And guess what? These heavy servers with only one application running on it, 99% of the time it just utilizes 5 to 10% of what they are actually capable of. Huh, that's a sheer waste of money and resources, right? That's the world before 2000. Then a cool company called VMware came up with a technology called virtualization. What VMware said? Every time you want to deploy your application, you go with a new server, which definitely comes with lots of cost. Now with virtualization technology, they offered multiple operating systems in the same host, which means you can run your application in isolation in the same server and same infrastructure, like running the application in a completely new server. Now essentially you were able to squeeze so much out of the same one server. Let's quickly see on high level how this virtualization actually works. So we still have the same physical server with an operating system installed on it, but now one server machine for many applications. We ensure that the applications runs in isolation via virtualization technology called hypervisor. It basically creates one virtual machine per application. Each virtual machine has its own operating system and each VM shares the physical server resource. Maybe Each one of these utilizes 30% of hard disk, 30% of RAM and CPU. And where do you install your applications? You install your applications in these virtual machines, which ensure optimum use of the hardware. Plus, it runs in isolation with dedicated hardware resources and hence avoid conflicts of dependencies and enhances performance to an extent. Now, if you want to deploy a new application, no need to purchase an expensive new server. Now we already have the server which is not fully utilized. So maybe just create one more virtual machine on it and deploy your application in isolation. Wow, now it looks all good, right? We're able to squeeze all the resources of this big fat server. But are we? Do you think that the allocated 30% is always used? If your application is not running for some reason, can you utilize these resources for other applications? Of course not, right? On top of that, let's say your application needs 10 GB RAM. So total hardware requirement as of now is 10 GB. But of course, since it is a virtual machine, a separate operating system has to run for the application. Let's say additional 5 GB for running operating system. Now the total RAM requirement for one application is 15 GB. That's okay. But say you have 10 such applications. So you need 10 VMs. So now the total RAM requirement only for the application is 100 GB. And again, of course, additional 50 GB of RAM for 10 operating systems. So now the total RAM requirement is 150 GB. That's a lot of RAM for running 10 applications. And guess what? The 50 GB is only for operating system. Looks like a lot of wastage there, right? Similar wastage will be there with other hardware resources as well, like CPU and hard disk. So it seems lot of wastage of company money. There will be definitely other additional cost. Maybe we need individual operating system licenses. Each of these VMs comes with other additional maintenance costs like additional patches, upgrading, driver supports and lot many. So of course VM brings a lot of advantages compared to the world before VM, but we have seen that it still comes with lots of disadvantages when compared to optimal uses of resources. Okay, enough. A lot have been said for world before container. Now let's see how does our Docker container works. So you still have a single server machine and you have an operating system installed on it. This could be something that is capable of running Docker, like Mac or Windows. Then on top of that, we install Docker Engine, also known as Docker Daemon. This Docker Engine basically runs in the background and manages everything that is required to interact with our containers. So using this Docker Engine, we create our containers. Now these containers are slices of our operating system and shares the same hardware resources. And in these containers, we run our applications in isolation. One application per container. These containers can be as small as 10 MB. So you can imagine how much space we can save. Now when it comes to virtual machine, it is exactly like a physical server all together with dedicated hardware resources, which comes with lot of baggage as discussed earlier, right? But this is not the case with container. When it comes to container, it optimally uses the same hardware for all our applications. Let's quickly list down few benefits of container. Company procures tools and technologies only if it gives a good return of investment, right? We have already seen how Docker can effectively use the hardware resources and reduce cost. As we have discussed, container can be as small as 10 MB, resulting in huge saving of space. And now, no additional operating system cost. Container shares the same operating system. No allocation of unused hardware resources. It is really fast to start and stop. Could be just a second to start a container. Load balancing of applications becomes really easy as you can create as many containers as you wish. And together with orchestration technologies like Kubernetes, it makes it even more effective. Huh, is it too many advantages? Looks like a boon to software industry, right? Let's look at the second benefit. A Docker container runs on any machine that supports Docker. Once you have tested your containerized application, you can deploy it to any other system where Docker is running. And you can be sure that your application will perform exactly as it did when you tested it. Hence, perfect for portability. It gives much better performance than compared to virtual machines. As mentioned earlier, containers are faster to create and quicker to start. Docker container works in complete isolation with all its dependencies within it. Hence, no impact from other applications' dependencies. Containers are immensely scalable. You can quickly create one container if demand for your application requires them. So, this is all about container. Looks like we have spent quite some time in understanding container. But believe me, if you have started appreciating the benefit of container, then it's all worth it. This is a course on Docker. Why we have been talking only about containers? Are you having this question? Actually, the core objective of all these concepts is to containerize our application to avail all the benefits that we have listed earlier. And Docker is just a platform that helps us to package all our application into images and run them as a container on any platform that can run Docker. So to summarize, Docker is basically a containerization platform. This essentially is a platform as a service product. This is all what is Docker as technology. So what's up next? Now I will show you how to install Docker. Then we will understand very basic and most important deployable artifacts, the Docker image. Then we will see how to pull images from Docker Hub and play around. Then I will show you how to run a container using an image, and we will go through lots of basic Docker commands. Let's install Docker. For that, open your browser and search for Docker. Most often the first link that you see should be docker.com. And this is the one which we are interested in as well. To install Docker, you have to download the Docker desktop and install. Installing is pretty simple for both Mac and Windows, and you can find the installer in all the sublinks displayed down here. But before downloading this, I would like to show you the prerequisites for Docker. Let's go to Docker documentation, click download and install. So you have here Docker Desktop for Mac and Docker Desktop for Windows. Currently I'm interested in Windows, so click it. You can see you have a link here to download Docker from Docker Hub. Now Docker Hub is basically a repository for Docker images, primarily for sharing purpose. You can as well create your own application image, upload it to Docker Hub and share it. We will be definitely pushing our images here, and of course we will download existing images from Docker Hub and play around later. But yes, Docker Hub also contains the installer. That is what this link is for. Now let's come to the point. You can see down here the system requirements. You should have Windows 10 64-bit, variants as well mentioned here. Hyper-V and container Windows feature must be enabled. Now Hyper-V comes with Windows 10, but it's possible that virtualization is not enabled. Hyper-V basically needs hardware virtualization as prerequisites. Virtualization is mentioned down here as well. So we will talk about that shortly later. There are a couple more hardware requirements like 64-bit processor, minimum 4 GB RAM, and virtualization should be enabled. To check if the virtualization is enabled or not, go to your task manager. In that, go to performance tab, and you can find here if the virtualization is enabled or not. Most often, by default, it is enabled. If not enabled, you have to go to your system BIOS and enable it. You can just search Google on how to enable virtualization in Windows 10, and you will definitely find many links suggesting how to do that. So now let's download. Let's go to docker.com and sign in. If you do not have an account, then please create one. it will be required for browsing Docker Hub later. So we have signed in, and right in the home page we can see download link. You know what? Before downloading and installing, let me show you first Docker command of this course, checking if Docker is installed or not. So open your command prompt and type docker dash dash version. What it says, Docker is not recognized as internal or external command. It means Docker is not installed in this system. Now let's go ahead and download Docker. It gives you an option to select for Mac or Windows. Let me select Windows. Download started and is in progress. It'll take some time, so let me fast forward. So download is over. Let's click this. Let's click OK. It unpackages the files and installs. It will take some time, so let me fast forward again. So installation successful. We have to restart our system. Let me do that and come back. So I'm back after restarting my system. Now we have to check if my Docker is working properly or not. For that, first go to your toolbar and mouse over on this Docker icon, and you can see it says Docker desktop is running. So all good. Let's get started with Docker by jumping into our command prompt. Let's type our version command, docker dash dash version, or we can even type docker-v. Remember, this command was not working earlier. It should work now. Yes, you can see the Docker version is here. It means our Docker is working properly. Let's quickly see if our Docker is working fine with Docker Hub as well. To test this, we'll just try to pull an image from the Docker Hub. You know what? Before that, let me quickly walk you through the Docker Hub. Let's go to hub.docker.com. Let's log in. Go to Explore. As I mentioned earlier, Docker Hub is basically a repository of Docker images. This is like a GitHub, but the difference is GitHub is a repository of code and Docker Hub is a repository of images. You can see these are all the official images. Now, what are images? We just learned about containers, right? But without images, there is no use of containers. You must have heard about object-oriented programming. Since I really appreciate object-oriented programming, so in that terms, images are like a class, bundled with all its properties and methods. And containers are the instances of that class. So you can have as many instances of that class as you wish, and similarly you can have as many containers as you wish from an image. Images are the application bundled with all its dependencies. But remember, the application inside that image is not running, which essentially means that with only images you cannot have your application up and running. So how can you run the application bundled in an image? As discussed, you need to run the image in a container. Let's go back to the Docker Hub. Let me search an image called Hello World. So we get this official Hello World image. Let me get inside this. This is the command to pull this image to your localhost. Let's go a little down. This is the command to run this image inside a container. So this image contains following information, which says hello from Docker. This message shows that your installation appears to be working correctly. To generate this image, Docker took the following steps and blah blah blah. Let's now run this image inside a container locally. So what is the command for that? Docker run hello world. Let's go to our command prompt and type docker run hello world. Just enter. So it is pulling the image from Docker Hub and it run inside the container. So you get the expected info. So let's quickly see what happened in the background when you give this command. Okay, say this is your host machine where Docker is installed. It means you have it here, the Docker client and the Docker engine. In your command prompt, you type a command docker run hello world. This command gets executed in your client and client makes a call to the local Docker engine. Docker engine looks for the hello world image in its local repository. In our case, since we are running this container for the first time, it does not find that image locally. So what it does? Yes, it makes a call to the Docker hub, pulls the image for you, creates a container, and run it locally, and you get the output. And at the same time stores the image in its local repository as well, so that every time you don't need to make an expensive download. Let me show you by executing the command again. See, it's pretty fast this time, right? Now let's go through all the commands which are important for getting started with Docker. Since we will go through these commands by playing around with images and containers, so let's pull a couple of images from Docker Hub. Before that, let's see if we have any images in our local host. For that, just type docker images ls. So we have one image right now. To list the images, we can even write docker images. See, we get the same list of images. This command gives few more info about the image, like tag, which is like a version of the image, image ID. You can always use image ID instead of image name, when it is created, and the size of the image. Now let's pull one more image. Let's pull Ubuntu operating system. What is the command for pulling an image? That's docker pull Ubuntu. So it is trying to pull the latest image. Pulling started. Now if you are not aware of Ubuntu, then it is one of the variant of Linux operating system, just like Fedora, Debian or Mint. So Ubuntu image has been pulled to local. Let's see how many images we have now. Docker images. So we have two images now. Now I would like to see if any container is running or not. For that, type docker ps. So we do not have any container running. Are there any stopped container? To see all the stopped and running container together, just type docker ps-a. See, we ran hello world image twice in two different containers, 5 minutes and 25 minutes ago, and status of both the container is exited. So it means there are no containers running as of now in this host. Let's run our hello world image once again. Since we ran the image in a container, let's see if there are any containers running. Hey, I just ran a container, but looks like there is no running container as of now. Let's type another command which will give me all the stopped and running containers. So our just ran container is available, but the status is exited. Can you tell me why? Let's pull in a slide to understand. Let's say you have an application, and when you execute command docker run image name, the Docker engine creates a container for you and runs your application in it. It means right now there is some process running inside the container. Now the moment this process stops, the container moves to exited state. So to summarize, for a container to be alive, a process must be running inside it. If the process stops, the container also stops and moves to exited state. That is what exactly happened in our case. The Hello World application just runs some process to print the message and then exits. Hence our container also exits. Now let's run our Linux operating system Ubuntu inside a container. Let's see if there are any running containers. No containers running. Let's see if the container is stopped. Yes, as expected. Because Ubuntu is an operating system and currently there are no processes running inside. Now, what if we want to interact with this OS? I mean, run some Linux command or install something to this OS? Can we do that? Yes, of course we can interact with this OS. Let's run this in an interactive mode. Let's do that. Docker run -i because you want your container to be interactive, -t as you want a terminal support as well for typing all your commands, right? Then image name Ubuntu. So yeah, you are now in the root folder of an Ubuntu operating system, which is right now complete isolated from your host OS, that is Windows. When I say OS, it gives a proper Linux OS environment, but of course without a GUI. If GUI would have been there, Ubuntu would have looked something like this. Now, as we discussed, say you want to practice some Linux command. Now, imagine the world before containers. What you would have done? You would have literally installed the OS in a separate machine or maybe install it in a VM, right? But now, just get the image and run it in a container and you are ready to practice all the Linux command. This Ubuntu container now behaves like a Linux VM. Let's type few commands. Let's say our Linux OS version. You can see this is Ubuntu 20.04. Let's clear the terminal. Let's print the current working directory. So we are in our root folder. Let's see all the folders inside this. For that, type ls. So since we have a lot of OS related folders, if you wish to create new folder, let's do that. Make directory test folder. Let's see if the folder is created. So our folder is here. Right now I just told you that you can use it for practicing Linux command, but believe me, there are a whole lot of advantages. You can even go ahead and install Docker inside this, create your CI/CD pipeline and lot many things. Let's move ahead and see how can we remove images. Let's come out of Ubuntu terminal. Let's remove hello world image. To remove images, type docker rmi. RMI stands for remove image. You can give either image name or few characters of image ID. We typed wrong image ID. It should be BF7. We got an error. What it says? Error response from daemon, which is our Docker engine. Image is being used by stopped container 239. So remember this. The image will be removed only if there are no containers are attached to the given image. If any container is using this image, if the container is running, then you must stop the container and then remove the container. And even if the container is in exited state, you should remove the container and then remove the image. So there are no containers running. But you can see there are 3 stopped containers which uses our hello world image. If containers would have been running, then we would have stopped them using docker stop container ID or name command. But since these are all stopped container, so let's go ahead and remove them. For removing containers, type docker rm container ID. Again, just few characters is also sufficient. So the container is removed. Similarly, let's remove other hello world containers as well. Now we should be able to remove our image. Let's delete the image now. Docker rmi image name. Image is deleted. Let's check that. So we do not have the hello world image now. Now I would like to show you how to do port mapping. I'll show you that by running a website inside a container. Let's go to my Docker Hub repository. You can see here, I have already pushed couple of images. I am interested in Hello World ASP.NET Core image. Let's go inside this image. It shows here the command used to push this image. Let's go to tags, and this is the command to pull this image. Remember that for creating such image, we have to write a Docker file, which I will be showing in a bit, where I will create a Docker file for a sample website, push it to Docker Hub, pull it in a testing machine and run it inside a container. But all this coming up in a bit. For now, let's pull this image to our local host. Since I had pulled this image earlier, so it just picks it up from the cache. See, we have the image now. Docker for teaching / hello world ASP.NET Core. So there is no container running as of now. Please don't confuse by seeing hello world image. We had removed them all earlier. But I again ran it for some reason. Let's run our ASP.NET Core image. So it is running now. Let's pull another command prompt and verify that. See, our ASP.NET container is up since 24 seconds. You can see here the application is listening in port 80. It means I should be able to access my application using port 80, right? Let's see that. Let me give my page name, that's home/index. Guess what? It gives HTTP 404 error, which means resource not found. Any idea why? This is because we have not done port mapping. This is an important concept. Let's try to understand this. Assume this is your local system where Docker is installed. So you have a Docker engine running in it, and inside that you have a Docker container, and inside the container you have your ASP.NET Core application running, and your application is listening in port 80 in the container. The reason I was not able to access the application using port 80 was because my web browser is outside my Docker host. So my web browser does not know how to directly connect to port 80. I have to tell the browser the port that it needs to connect to the Docker engine, and then the same port should be mapped to the container. It means there should be a port mapping done between my Docker engine port and the port exposed by my container where my application is running. So similarly, I can run different instances of same or different applications on different ports on Docker host. So now let's do the port mapping and run our application in a container. Let's type the command docker run -p. We have to use this flag which tells the Docker engine that we are going to do a port mapping. Then give the host port and then the container port. And finally the image name of the image which you want to run inside this container. Now 8080 port is the port in the host machine. So if the request comes to 8080, Docker engine will internally forward the call to the port 80 in which our web application is listening. So we have done the port mapping and our container is running. Now let's go ahead and run our application in browser. Boom! Our application is running from the Docker container. Of course, a single page which says welcome hello world from Docker container. So our web application container is running. Let's stop the container. Let's refresh the web page. Our application is gone. This is because we stopped our container, right? Let's run the container again. Let's go back and refresh the page. Our application is back. Have you observed how fast and easy it is to up your application, and at the same time, if you wish to stop, just requires a second. Awesome, right? Now let's move to our next section. So up next, we have this website. We will create a Docker file for this application, build an image out of the Docker file, push the image to the Docker Hub, Then pull the image from Docker Hub to another system where there is no supporting software installed for running the application. I call it as test machine. Finally, we will run the image in a container in that machine. So let's get started with what is Docker file. Docker file is a file that contains list of commands and instructions which are executed in sequence for building a Docker image with an application inside. I hope by now you are already aware of images. As we have seen earlier, images are the applications bundled with all its dependencies, and Dockerfile is used to create these images. Let's flip to VS Code. This is an ASP.NET Core application and I have opened it in VS Code. VS Code has an awesome extension which helps in managing our Docker container, images, and all that is required to work with Docker. I'm going to use that for this demo. Let's install the extension. Search for Docker, select the first one and install. I'm not going to go in detail about this extension. I'll just use what is required to containerize this application. Please comment and let me know if you want me to create a video on this. So our Docker extension got installed. You can see here a small Docker icon now. Let's click that. See, you have a nice user interface now. You can see all your available local images here, your running containers here, and many more. Now let's get started with building our Docker file. You know what? Before that, let's run our application and see once. Let's copy this URL and run it in browser. So this is the website for which we want to create an image using a Docker file. So let's do that. Let's use our great Docker extension for that. Go to command palette. You can see here build images option. If you are not getting it, just type images. Just click it. Down here you can see it is asking for creating a Docker file. Couldn't find a Docker file in your workspace? Would you like to add one? Yes, we want to add it, so let's click yes. Now it is asking the application platform that we are working with. That's ASP.NET Core. Which container we are targeting? In this case, it would be Linux. And the port that our application will be listening on. Let's make it as port 80. We do not require Docker Compose file, so let's click no. You can see our Docker file got generated for us. Yes, of course you can type this all, but if we have a tool which can reduce our job, then why not to use it, right? And of course I will go through each line and explain you what are all these. So before building the image, let's go through this file. Now this different group of lines in this file creates a layer in the image. Basically it uses containers internally and subsequently the next layer are built on top of the previous layer. This is also known as a multi-stage build, which helps to optimize the size of the Docker image by ensuring that it does not keep adding to a single image, which can make the image bigger. So the first line tells that we are going to create an image of an ASP.NET Core application and the layer is named as base. This is basically an ASP.NET Core runtime which is required to run our application, but definitely not for building the image. The compiling will be done by SDK, which is down here. This is done so that the final image contains the thing that is required to run the app and not other things like files used to build the application. Line number 2 sets the working directory as app, and then we set the port where we want our application to listen, which is 80. Line 5 takes .NET Core SDK image, which is definitely bigger as it contains compilers and stuff like that to build our application. But again, it does not include the .NET Core runtime as it is not required to build the image. Line number 6 sets the working directory as source and then copies the project file to the root of the working directory, that is source. As we know, this project file specifies all the dependencies, hence it restores the dependencies here and then copies the restored files to the current folder and sets the working directory to current copied folder inside source. Then in line number 11, we run .NET build with a configuration flag of release and place the output of that, which is basically a compiled project, to a folder called app build. And in line number 13, from the build image which we tag as publish, we run the command .NET publish again with a configuration flag of release and place the output of that folder to a folder called publish. Line 16 takes our initial base image which contains only .NET runtime because that's the only thing that we need to run our application. Line 17 specifies the working directory again for this container. Line 18 copies the content of our app publish folder to the current working directory. And finally, we specify our entry point, which basically tells how do we want our application to run, or we are saying here when someone runs our image in a container, then what should it do? It should basically call .NET command followed by the executable. So that's all about the Docker file. If you want to know more about Dockerfile, then please do comment and let me know. Now, let's build our image. To build image, we can use the GUI as well. Just go to command palette and type build. You can see here, that's the build image option. You can click this and go ahead with building the image. But for now, I would like to manually build it by typing the command. So let's do that. Docker build. Let's give it a name. For that, use --tag option and then image name. I would like it to be Docker for teaching / Ryjanix. And then don't forget to give this dot. This tells the Docker that the Docker file that has to be used is in the current directory. So the image build started. I had already built this image once earlier, so the build process will be faster for now. Otherwise, it generally takes time as it has to freshly execute all the commands mentioned in the Docker file like restoring dependencies, building the application, etc. So, build completed. Let's see if the image is available. Yes, it's here. Let's run the image. Will this work? Let's try to open the site in our web browser. As expected, it does not work. Do you remember what we are missing? Yes, that's port mapping. Let's quickly do that. Let's update our URL. See, our web application is up and running from the container which is created using our image that we have built just now. Now let's push the image to the Docker Hub and pull it in a test machine. How can we push an image? That's simple. Just type docker push image name. That's Docker for teaching / Ryjanix. So our image is pushed to the Docker Hub. Let's go to Docker Hub and verify. See, that's our image. So let's see what we have done till now. We had a developer machine where we have created our application and then created a Docker file, built an image of our application and then pushed it to the Docker Hub. Now, what we can do with this Docker image? Yes, we can ask our tester to pull it to their machine and test the application, right? or deploy the application to our staging server, or deploy it to our production server as well. The beauty is that it will work exactly the way it worked in your system. And what is required to run this application in any other system? Just we need to ensure that Docker is available there, because this image contains all the dependencies of your application. Awesome, right? Now let me switch to a fresh system where only Docker is installed and pull the image and run it. So I have logged into my test machine. Let me go to my start menu and search for Visual Studio. That's not available. Even VS Code is not available here. Let me open a command prompt. Let's see if Docker is running. So we get the Docker version. It means Docker is up and running here. Let's see if we have any images here. Seems we do not have any image. Now let's pull our Rygenix image. Pulling is started. Since I am pulling this image in this machine for the first time, it will take some time. Let me do a fast forward. So the image is pulled. It took me around 2 to 3 minutes to pull this image. Let's verify if the image is available. Yes, that's there. Now let's run it in a container. And that's our application. Now we can start testing it. I hope you have realized that how easy it is to distribute your application. Finally, we came to the end of this course. It was really fun creating this video. I hope it was interesting and informative. Please do comment and let me know. And do share this video with others. Thanks.